Hello all, today we'll be covering using Istio to supercharge your Kubernetes cluster. So this session will be helpful for people who are either already running Kubernetes clusters uh, or looking to solve problems that comes with microservices. So let's get into it. So today what we'll cover is um, why do we need it and give it a context in line of thinking on monolith versus microservices. And while there are all the good reasons to adopt microservices, there are a lot of challenges that come only in a microservices environment. So we'll look into that. Then look into how Istio's architecture and features, especially around traffic management, security, and observability, helps us address those challenges. We also will be looking at how Istio integrates with GKE, which is Google Kubernetes Engine, Google Cloud's managed version of Kubernetes. And then there are some use cases with some customer examples that I'll use, which we'll cover here. With that, let's begin. So before we understand what Istio is and its working model, let us first talk about why it is needed in the first place. Changes in service architecture. Apps changing their services from monolith architecture to microservices rapidly due to advantages of microservices such as CI/CD, updates, ability to scale individual elements together. Now, when we do come to this world, what happens is you have to look at some of the base architectural differences, and that introduces a set of advantages and disadvantages. So monolith have advantages such as easy to develop, test, deploy, um, horizontally scale, but it has a lot of other disadvantages too. For example, applications becomes too big uh, and complex to comprehend. Updates are a pain. Continuous deployment is hard, difficult to scale if different modules have different resource requirement. Reliability is a concern. For example, a memory leak in one module can bring the whole app down. Changes in the frameworks or languages can affect the entire application because essentially a monolith will be written in one language. You don't have the flexibility to integrate multiple languages in a single application. And the benefit with microservices you get when you divide the app into smaller services is you are able to faster to develop, easier to update, and address all the disadvantages that I was just talking about, which is present with monoliths. Having said that, there are some significant challenges with microservices, especially if you have a lot of microservices around that are running. How would they be interacting each other? Calls that were supposed to be a function call or an IPC call, now they are suddenly becoming a networking call because these services are not hosted together. They are being called each to each other on the network. How would you route particular traffic? Naming and discovering also becomes a challenge. How would you load balance, right? In monolith, at least when the traffic is coming, you are scaling up the whole thing. The promise of microservices, you can scale individually, but how would you go about doing that, right? Logging and monitoring. Then also it gets extended to things like debugging, troubleshooting. If say your application is slow, how do you know which microservice is responsible for that slowness? Where exactly is the problem? So a lot of these challenges do come with microservices, and there is like a nice cartoon that just outlines this. Is you have got microservices and one of your service is out of the control, and now you are like pretty much upset that your services. And then we are saying, hey, maybe microservices adoption at this point was not a mature decision to do. So think of Istio as the component that helps you achieve the microservices dream while solving a lot of these challenges that comes with adopting microservices. So what is Istio? So Istio is a platform that lets you connect, secure, control, and observe microservices. And in general term, or the industry term that we use for umbrella term that we use is now called service mesh. What does it do in terms of it will help you reduce the complexity of deployments by presenting a view of the service mesh, how the services are connected together, how the traffic is flowing. You will be able to even direct the traffic percentage that will be talked about. And it has an open API that allows you to integrate logging, monitoring, telemetry, and policy with it. In addition to all this, it also offers load balancing, authentication, and monitoring without changes in the service code itself. Now, this last bit is fundamentally important. You all have a written application that does some monitoring, but often what that process requires you to do is make changes to the application to get those features going. The promise of Istio and what it achieves is we give you all of these features, and none of these features require you to change your application. You may ask, how are we doing it? What's the sorcery behind it? So we'll look at it soon. So let's look at features and architectures. So the core features, as we just talked about, is traffic management. So in traffic management, things like request routing, shifting the traffic itself. So traffic shifting essentially means you have pushed an update and you want to shift smaller percentage of traffic towards it. And as you see success in that new update, then you would want to gradually shift the entire traffic. Ingress and egress control, how the traffic flows, whether you are getting data into the cluster or you are getting data out of the cluster. Do security, like doing authentication and authorization, making sure the traffic between even your clusters or the pods each other are also encrypted and safe. And then observability, so things like logging, monitoring, telemetry, and service graphs. So if you look at the high level architecture, we have data plane and control plane, and let me take you through one by one. So the data plane is composed of a set of intelligent proxies, say Envoy, deployed as sidecars. Now these proxies mediate and control all the network communication between microservices, along with Mixer, which is a general purpose policy and telemetry hub. The control plane manages and configures the proxies to route traffic. Additionally, the control plane configures mixers to enforce policies and collect telemetry. Pilot converts high-level routing rules that control traffic behavior into envoy-specific configuration and propagates them to the sidecars at runtime. Citadel also provides strong service-to-service and end-user authentication with built-in identity and credential management, so that you don't have to do anything special on your side. All of this is also covered in the following link at the Istio homepage called istio.io. So now we have talked about sidecar a lot, and I have also talked about how you do not need to make changes to the application. So let's look at what is the sidecar. So we are using Envoy proxy with a sidecar pattern. And what happens is all the requests that comes to your container, it's actually, there is a reverse proxy, which is an Envoy proxy that looks through it. It makes everything possible. So it knows that what traffic should flow through, what is the data that needs to be generated out of that traffic, and we use that traffic, send it to central Istio systems to do monitoring. So it is involved in dynamic service discovery, load balancing. It also helps you do TLS terminations so that your application don't need to do it. It does health checks, stage rollouts, what have you. And it is deployed as a sidecar container in the same K8s pod. And if you remember it from your previous, Kubernetes knowledge that a sidecar is a collection of a pod is a collection of containers. So one pod is, let's say, your main application. A sidecar would be another Docker container, which is an Istio application that is then making up a single pod. It observes traffic attributes from a service and hands them to Mixer, which uses them to enforce policies and monitoring systems. So let's look into traffic management and how that works. So Kubernetes traffic management is mainly infrastructure based. So it gives you control over how traffic reaches to the pods, but rather than specifying which pods should the traffic reach to, Istio does it a little bit differently. Istio lets you define the rules to specific policies. For example, decoupling traffic from infrastructure. Traffic routed to a version is independent of the pods running in it. So it offers config rules that allow finer control over APIs and traffic between services. It greatly simplifies the configuration of service level properties like circuit breakers, timeouts, and retries. It is easy to set up critical tasks like A/B testing, canary, staged rollout, and do traffic splits. And it offers better visibility into traffic, easy to catch issues, and make your services reliable and network robust. So as you can see, I was in this example, I have a new canary version of the software. I am able to divert 5% of the traffic on it. The other component is Pilot, which is essentially the core component for traffic management that manages and configures all Envoy proxy deploys. It exposes rules API for intelligence and routing and consistency. And it converts high-level routing rules into Envoy specific configuration and propagates them to envoys. All of this happens in the backend, so you don't have to do anything yourself. And you just have to use the Istio provided APIs to do these things. So if we look at the basic traffic configuration model, here are the things that matter. So there is a virtual service, which essentially is a set of rules that control how a request for a service are routed within the mesh. Then there is a destination rule, which talks about how after a virtual service routing has been done, a specified set of policies that needs to be applied there. And then there is a service entry. So any request that needs to happen to outside mesh, we control it via service entry. And gateway. So this allows you to set up either HTTP or TCP load balancer, which allows you to enable traffic from outside the cluster to reach to an application. Think of this as an external application, so to speak, external users. So let's look at what a virtual service looks like. So these are essentially a set of rules that control how requests for services are routed to each other. In this example, what I have done is there is a route that I have created, and I have given the weight distribution of 75 and 25. And so what will happen is 75% of the traffic will go to V1 and rest of the 25% of the traffic will go to V2. Requests can be routed based on request source and destination, HTTP paths, and header fields, and weights associated with individual service and versions. And it can be used to configure other things also, which are very important, things like retry logic and even injecting false if you're testing something. So think of how would you do timeout. So essentially on timeout, you can set up a field called timeout under HTTP, if it is appearing here, 8 seconds, and then you can also do retry. So typically what you'd want is, in a microservices world, if the service that you are calling to is experiencing failure, you'd want to implement exponential backoff rather than quick retries to make sure the service is able to get back to the health without other services killing it with too many requests. Fault injection, essentially I am testing a service and I want to introduce a delay. You can go ahead and delay by using a fault category, and under that you can say what is the delay you are looking for and what's the percentage and the delay duration. You can even do a custom aborts inserted in applications, and you can say, okay, 10% of the application I want to get HTTP 400 error code, and I want to see how the other services are reacting to it. So it is getting that sense. In Google, what fault injection is core to how we manage the reliability of our services, and this allows you to do it as well with fairly simple semantics. You can do conditional routing as well. So if something should match, then this is where the traffic should go. So this allows you to either do it on source level, or you can do it based on end user. You can do many different configurations here in terms of how you want to reach a rule. So let's look at destination rules now. So after a virtual service routing has been done, so destination rule specifies a set of policies that you want to apply to that request. So this is used for describing circuit breakers, load balancer settings, and even TLS settings. And it defines addressable subsets, which are further used in virtual services specification. So in the example shown here, what I'm showing is the traffic policy. So one of the things Istio does is it has the ability to do, say, load balancing, what kind of load balancing you want to do. And depending on which version you want, you can have different kind of load balancing techniques being applied here. Then there is a service entry if something that needs to reach outside. So in Istio already has like a service registry internally, and a service entry is used to add additional entries into this registry. So most commonly used to enable requests to services outside the Istio mesh. So here I have like a full external service, which essentially is running on this host and running on these ports. Gateways are essentially a way to configure load balancers that allows you to have traffic at the edge of the mesh to enable ingress. It differs from Kubernetes ingress in a way that it configures only L4 and L6 functions and not L7 functions. And to control HTTP request, standard Istio rules are to be used by binding virtual service to it. And in this case, you essentially have like a gateway which I'm binding to it, and then there are a specific host. And this is an example from the book info application, which is available on the Istio website for you to try and use. Let's talk about security. So microservices introduces a new challenge, which is security, and a lot of us don't see it until we have to go about doing it. So right now, the typical security model that we implement is each of the services, microservices that are running, we by default assume that those services are trusted entities and they can talk to each other without any additional auth in place. So if you were to put encryption in the communication channel, then there's a lot more stuff that needs to happen. What Kubernetes does is it allows you to have mutual TLS for fine-grained access policies to provide flexible access controls. And it manages all of this: authentication, authorization, encryption of service communication at scale. And it allows you to enforce policies across different protocols and runtimes with little or no change in the applications. So let's look at how Istio does this. So Istio identifies the fundamental concept of the security architecture, and the communicating parties must exchange their identity information for mutual authentication. The client checks the server's identity against a secure naming to verify if it is authorized to run the said service, and the server determines the information that can be accessed by the client via authorized policy and audit access logs. On GCP, the GCP service account acts as an identity for each service. So the way authentication is provided under Istio is in two types. You can use a transport authentication, which is service to service authentication using MTLS, or you can use an origin authentication, which is useful for doing end user authentication. So is the client an end user or a service? So you basically do a JWT or JSON Web Token based validation. Authentication policies are stored in Istio config store via the normal Kubernetes API. So let's talk about MTLS. And before we cover MTLS, let's talk about TLS itself. So TLS proves only the identity of the server by default. Pilot watches the Kubernetes API server, generates the secure naming information, and distributes it securely to the sidecar envoy. And these MTLS these MTLS sessions are established between the envoy proxies and the communication services, both of these parties. They start the handshake and does a secure naming check to verify if the service account in the server certificate is authorized to run the service. Client and service establish an MTLS session, and essentially the traffic is forwarded from client envoy to server envoy. Once the client is authorized, the traffic is forwarded to the server, and secure naming contains the mapping of identities and service names. Here is how authorization works. The mesh administrator specify the authorization policies. These are saved in Istio config store, and pilot distributes these policies to the respective envoy proxies. So this is how the security architecture looks like. I will not go too much into detail here. So the important thing is just to look at the flow that goes here. So Citadel issues the keys and certificates to envoy proxy. Envoy implements the secure communication. Mixer is actually managing the authorization and auditing, and pilot then distributes the policy and secure naming information to the proxies. And these secure policies can be implemented at different levels of granularity, whether it could be service, namespace, or even on mesh level. This is my favorite part, which is the observability. So many Kubernetes users, as you typically will see, as the number of microservices grow, it will be very difficult to manage, monitor, and observe their performance. A lot of large teams will build a lot of custom tooling to get these things done, but it often requires heavy work. Istio offers some significant things that we'll cover in the demo part of the presentation section, which I hopefully will be able to get to on the time, which is tracing, monitoring, and logging of the service mesh. Custom dashboards that offer visibility into the performance of services, and fine-grained control over service communication. And since it gets you a lot of data which is actionable, it also lets you enforce SLOs on the services, service level objectives that you would have set for your services if you are following the SRE practices. And it allows you to quickly know which service is causing the problem, so you can do efficient debugging in the entire process. Some of the system it integrates with is Prometheus. So it spits all the data to Prometheus. There is a built-in adapter in the mixer that exposes an API for serving these metrics, and we can query the mesh, mixer, and even envoy metrics with Prometheus, and I'll show you some of these in the demo. This is the observability bit, where what we have done is we are using the data that is exposed by Kubernetes in a Grafana dashboard, and this allows me to see things like a mesh summary, individual services view, and even looking at individual workloads. There is also another important bit is service graph. So Istio generates the data that allows you to see a graph of services, and endpoints are provided by the service graph and the service graph technology can then pick this data up and build out this graph. Look at this graph, which is essentially plots a book info application which is available, which was the sample I was just talking about, which allows you to see Istio ingress. It comes to product, and I can visualize the exact latency between various services and also the flow direction. So a lot of times you should have this documentation. It not just allows you to know what is the time spent on each of these services, but it also helps you gain a deeper perspective on how these services are arranged. And if you have like a lot of services, this is a way to generate a service dependency graph very quickly. The flexible plugin model enables Istio to interface with a different of host, environment, and infrastructure backend, and thus Istio abstracts the envoy proxy and Istio managed services from these details. and mixer handles all of this. So the control plane component that enforces policy, access services, it collects the telemetry from the envoy proxies and provides a nice plugin model where we can do all of this without breaking head. If you are using Google Kubernetes engine, then getting started with Istio is quite easy. So there is add-on called Istio on GKE. When you are launching a new cluster, all you can do is you can select, hey, deploy Istio with it as well, and you will be able to get it. All of these data gets sent to Stackdriver as well. So you can view in Stackdriver or via various techniques that I was just showing you right now. You can see in the deployment section all the pods that are running in the Istio namespace, and these are things like Citadel, Pilot, Policy, Tracing, all the stuff that I was talking in this presentation. So let's talk about some of the real life use cases for Istio. So hey, you have a problem, how does Istio solve it? So everybody, so this is a comment from an early adopter, everybody got all fired up about Kubernetes and microservices, and they're like, okay, what's going on? Istio gives us a view of entire system and lets us find trouble spots. So that's the number one use case that you'll see a lot of folks be very excited about. You set it, you forget about it, all the details you don't need to know. You just inject Istio sidecar everywhere, and now you have plenty of data for you to look at to understand the problems. So Istio will gather golden signals for each services, whether it is traffic, error rate, and latency. It detects the dependency graph, meaning which services are dependent on which. It gathers logs and send to a common destination through Mixer. So Istio sends traces through Mixer as well. In one of the use case where they use a microservices based architecture, have complex dependency. Before Istio, when a service get loaded, they would learn by watching existing indicators, CPU, RAM, logs, all are like indirect observation. But after installing Istio, they would get the direct observations about the traffic. In terms of security, if you want security, you can have MTLS, and there is a comment from AutoTrader where they said we are predominantly a Java house. We are worried about TLS termination in Java apps, because if you do TLS termination in Java apps, the overhead is significantly higher. And since the TLS termination is available out of the box in Istio, it was like quite simple, and they enabled it, and it was all done very quickly in just a day. And advanced networking. So a lot of practical applications and a lot of best practices you can do. So for canary deployment, you would want to test out the traffic with small traffic before you scale it to a larger system. You will be easily be able to do that. You can do canary testing without doing anything advanced in the system. You can use things like Envoy's native capability like circuit breaking, fault injection, and retry logic to make sure that as you scale, you don't end up breaking the services. So things do continue to work. You are able to test your systems properly. You have nice retry logic. You have nice fault injection going. So that ends the presentation. What I will do now is I'll take you through the quick labs part. As part of this this bit, what we'll have is we'll give you access to the quick labs environment, and these are code labs, but with a cloud environment set up for you. So this allows you to go do it, experiment, get your hands dirty yourself with some of the technologies that I talked about. So and I'll go into the quick lab that we have created. So let me just show you what we have. So if you go to this URL, we have something called Anthos Service Mesh, which is nothing but Anthos version of the Istio that we have with some additional features. But you don't have to worry about, so if you look at the quest outline, it covers the things that I was just talking about. So either you watch these videos or you can probably treat it as optional because the introduction you already got it, but feel free to check this out. Then there are labs on installing Istio on GKE add-on with Kubernetes engine, which I was talking about, or how would you install service mesh on Kubernetes engine, and then observing the services with Prometheus, Grafana, Jager, and Keali. So this is what I will try to quickly cover now. Then basically you will be prompted to log into Quick Labs. If you don't already have an account, do create it. And when you start the first lab of the quest and in the lab, you get the 1 month subscription that will automatically get added into your Quick Labs account. And you'll be able to take any lab or quest free of charge once that subscription is activated. Running the lab is pretty straightforward, which I will anyway show you now. So let's get to lab now. Okay. So what I have done is I have this lab already running, this observing services using Prometheus, Grafana, Jager, and Keali, and it gives you this username, password, and the project ID. So the way you use it is you don't directly click because this is a new Google account that got provisioned for you. So it is often helpful that if you have like a different profile or an incognito window where you can do this. So let me switch to a window where I'll be doing this. Okay. Okay, so you can see the guest profile now. And what I'm doing now is clicking the link of Open Google Cloud Console and pasting it here. And I have this username, which is quicklabs.net, and password. Accept this and get in. Okay, so now you can basically see a GCP project that was created for me, and there are already some resources deployed in it. So let me quickly show you. So if I go to Kubernetes engine, this is the cluster that is already set up for me, and if I go into details, you will see this is the Kubernetes cluster. These are the number of nodes, and all the details here. And you can go to look at workloads, and what you have essentially available is you have various workloads that are running, and if you want to look at services, you can go check out that as well. So Istio Citadel, Ingress, Keali, Pilot, all of these things, and services where you have like external load balancer where different services are running on different ports, and we'll be consuming these services just now. Now, what we need to do, okay, one more thing. So in order to run all the commands, you can use this Cloud Shell, which allows us to execute commands and do a lot of development and fast track it. And some of the features that are present here is quite amazing, especially the remote port forwarding to local systems like this. Okay, let me just increase the font size here so that you are able to see it more clearly. Okay, I hope this text is visible. If not, do let me know. Okay, so now what I'll be doing is the lab window that you are not able to see now essentially contains all the instructions on what needs to happen. So as the initial setup, what is required is you would have already seen the cluster name and cluster zone. So I'll be setting those up. The cluster name is central and the cluster zone is US Central 1B. And what I would want to do is the kubectl command, I would want to essentially get the credentials there. Once that those credentials are available, I would be able to essentially run kubectl commands. If you want to look at the cluster in the command line thing like the cloud container clusters list, you will see here I have like a 4-node cluster that is running. And Istio, what all services, service -n essentially mentions the namespace, and we have Istio-system namespace, where all the Istio services will show up and which ports they are running on. So you can see these here. As we move along, what we'll do is we'll be working on our book info deployment, right? So we don't want to look at the system pods now. We'll look into this. So book info application, which I was just talking about in the presentation, is already deployed here. And you can see details, product page, Kubernetes, rating, reviews, all of these services are already running. Now, what we need to do is we need to generate some traffic so that all the monitoring systems have something to monitor. So what I'll do is I'll execute a curl command with the service name to basically generate some traffic. So what I did is I went in the application, it returned simple, bookstore application. It's an HTML output that you can see there. Okay, so let's look at the Istio ingress gateway IP address so that we can go communicate with this. And you can see this is the external IP that is already generated for us. We'll take that external IP and set the environment variable so that we can generate some more traffic in the application, see what the info looks like. So if you go to the gateway page, this is what this is what you get. So okay, it is being served from envoy, upstream time is this and that. So you know everything is up now. So first what we want to look at is see what kind of metric that you can get from Grafana system, right? So what we have done is we have just taken a look at the Istio ingress service, which is still running in 35.232.135.218. Our gateway URL is already set up, and now what we would want to do is, so instead of monitoring in Prometheus, and due to lack of time, I'll directly show you the Grafana part. It's a lot more prettier and it is all set up, so that would be a lot better. So let's look at the Grafana's cluster IP address. This is the IP address which it is running on, and let's set up a port forward. So what we'll do is this 3000 port, I'll try to connect it from this current system. So Kubernetes kubectl port dash forward command allows us to port. So now Cloud Shell has this 3000 port forwarded, and what you can do is you can use web preview to get access to that port. So you can click change port and say, hey, give me this 3000 port, and click on change and preview. And what it will do is it will open Grafana service that was just hosted in there. So it is opening. What we would want to do, just have some traffic also coming into the cluster. So you go to manage, and you have this Istio. And as you can see, there is Istio mesh dashboard, mixer dashboard, service dashboard. So you can open something like Istio mesh dashboard. And here you can see currently the request volume is only 0.03 ops per second. There is a global success rate, and all of this detail are here. And as you run the command, let me generate few synthetic traffic again. So what I will do is, just give me a second to get the sorry. So I have the gateway URL done. Now I'll just quickly generate some traffic. Okay, so as I'm generating the traffic, you will see the global ops per second go increase, and you will see the success rate and these metrics get populated as well. So you see it got increased to 0.051 ops per second. The other bit is you have also the ability to see things like Istio service dashboard as well. So if you go to manage again, click Istio, and then there is service dashboard. So here you will see all the details from Istio services that we have just set up. So you get details like, again, I'll set the service to, I'll run a command to generate the traffic again. So let me just quickly do, I should have done it on the watch part. As we are generating this, you can see the client success rate, request volume, and this is for this service, which is the cluster.local. And you essentially have other services like you can do details, product page, rating, any service that you would want. And you have these details like what is the response, whether non-5xs response is that, what is the incoming request size, what is the incoming request destination and response code. So all of these details are simply available to you without you doing any additional work. Another important feature that you get is, let's close this part and focus on the other bit, is the tracing bit. So Jager is a distributed tracing tool that allows you to view this data. So what you can do is the gateway is already set up and we have generated some traffic. Let's generate some more. And what we'll do is we will, just like how we have done port forwarding for Jager, we will do port forwarding for Grafana. We'll do it for Jager as well. Jager is running on 2001 port. So similarly, you click on web preview and say 2001, not 001. So give it some time. This will open. Okay. So this is the Jager UI that is opening, and I will use product page.default, and then I can click find traces button. So this already has traces. So for example, product page on default service cluster took 30 milliseconds, and you can click on this span to understand how this traffic has been distributed, which part it actually spent various time on. So there is like 2 milliseconds spent here, and then ratings.default itself took this much time. You can essentially click and see additional details about what the tags associated and which process it got connected to. Okay, so now moving forward, I have one more thing to show you, which is very interesting, is the Keali service graph. So let's get out from this one, and you can tap on get, and it is running on port same 20001. So you don't have to do anything here. But for Keali, what we need is we are going to need a what we'll do is we'll set up a watch here. So this will keep on generating the data for our cluster without us going back again and again. So let us do a port forwarding for 20001. It is now forwarded, so it is already set to that. So I'll just click on this. So the default username and password for this is admin. Once the UI comes up, let me, okay. So I'm in Keali now. Yeah. So we are getting in. Okay, so you can see I have a default application, and then there is Istio system. So we don't have to monitor Istio system itself. I'll hope Istio developers are doing a nice job. So we'll worry about our system. So let's click here. And now I am in the namespace default, and you can see by service, what is the health of these services that are available. And then what you can do is you can click on the one of the services. So say I'll click on product page, and you can see it on the graph itself. Like, so as you can see, maybe this is a little bit smaller. Okay. So you see Istio ingress is connecting to product page is taking you to details, and then you're going to reviews. And out of all the traffic, so far we have not got any errors. In real production, you will have some errors as well, which could be demonstrated here. And we can add things like request per second. So again, this is a test app. So the RPS here is like 0.69 per second. We also have things like, say, request percentage. So what percentage of traffic is being distributed? So out of the 100% traffic that is coming to product page, 50% is going to details, 50% is going to reviews, or you can even look at like response times. So this information is essentially helpful if you are trying to debug a particular application in a certain way. What you can do is you can see a traffic animation also. So this basically shows you how the traffic is flowing. And this is real time, by the way. So we don't generate it and then leave it. So this is how the traffic is actually flowing. So you know, key flow is from Istio ingress gateway to all the way to this path. So this essentially allows you to, and you are even seeing the protocol that we are being connected to. So very powerful stuff. And like I said, no developer overhead. It's just a matter of having things set up and then you viewing all of this.